All right, let's see if we can't get this in one take. So, question 11 asks, what is the side length of the square to the right? And then before that, we're given information. The area of the square represented to the right is measured to be 120 inches squared. And we know it's a square, so we know then that this side and this side will be equal. And so how do you find out the side length? Well, we know that the area of a square equals the side squared. So therefore, to do the opposite, you just need to take the square root. We can say the side equals the square root of the area. And we know the area. It is 120. And so to get square root, we need to look at our calculator. It's right there above x squared. It's in green, so we have to hit the green button on our calculator and then click the square button, and we get the green version of that button, which is square root. And then we just type in 120. You need to make sure you hit that 1. So let's go ahead and try it again, 120. There we go, and hit enter. And I get this weird rational answer. Anytime you get any kind of answer like this, just hit this button on your calculator. It'll convert it. If you hit it again, it'll convert it back. And so just an example of that would be if I had 0.5 and I hit the conversion button and hit enter. It gives it to me in a fraction. If I don't want it as a fraction, if I want it as a decimal, I hit it again and it gives it back to me. Just so you know how this button works. One more example of that would be like if I wrote 10 pi. I hit enter and it gives me 10 pi. Hit that conversion button and it'll convert it for you. But what was the answer there? The square root of 120, if we go back up, it was 10.9544. And so we'll just write 10.95 because it says precision of 0.00, which means round to the second decimal place. That 4 rounds down to 10.95. And then, of course, don't forget your units or you will lose a point. And so this is 10.95 inches. The next question asks, what diameter of a circle would you cut out of the square in order to have a remaining area of 70 inches squared without the circle? So for this to be 70 and for the entire thing to be 120, we would need this inner circle to be 50 inches squared. And so we know the formula for the area of a circle. The area of a circle is pi r squared. And we also know the formula for a diameter is just 2 times your radius. And we know our area. We just said it has to be 50. So we can say 50 equals pi r squared. And then can we solve for r? Okay, well, we can divide by pi on both sides. And if we do 50 divided by pi, so 50 divided by 3.14 gives me, and hold on, let's go ahead and clear all this and let's try typing it again. 50 divided by 3.14, what do I get? 15.92. And you might ask yourself, should we write pi instead? Well, let's see what we get if we get a different answer. 50 divided by just pi, what do we get? We still get 15.9. In this case, it's 15.91. In this case, it's 15.92, but that 91 rounds up to 92. And it says round to the first decimal place, and it gets the same answer to the first decimal place. So I'm not going to concern myself with which one it is. Although you will get the same answer, or you will get the right answer no matter which one you use, for the record. But anyway, okay, we can rewrite this formula then. Pi cancels out on the right. We get 15.9 equals r squared. And so to solve for r, I'm going to take the square root of both sides. R cancels out on the right, and we just learned how to type in square root in this calculator. Second square root of 15.9. And what do we get? We get 3.987 for my radius. And so we can just simplify that to what? 3.99 equals my radius. And then so therefore, what is my diameter? If I multiply this by 2, what do I get? I get 7.97. So my diameter is 7.97, but it says round to the first decimal. That's what this says here. And so this rounds to the first decimal up, we get 8.0. That is the correct precision. You do need to add that 0. That's how this system rounds. And of course, don't forget your units. The diameter would have to be 8 inches to get that remaining area. All right, what about question 13? What side length would you specify if you were required to create a hexagon plate that was comprised of 99 centimeters squared of sheet metal? In other words, if this entire thing had an area of 99 inches squared, what would this side length have to be? Let me move this formula in that you will have on the test so we can take a look at it. I'm going to put it right here. And if we look, we've got two different formulas that we can use. One has F in it and one doesn't. We don't know F. That is the diameter of a circumscribed circle. We don't know that length. And so I'm going to stick to the other equation over here. So we can rewrite this to say our area equals our number of sides multiplied by the length of the side squared divided by 4 tan and then 180 over the number of sides. And we know our area. It would be 99. And so I can rewrite this to say 99 equals our number of sides, which we also know there are 6 sides on this hexagon, times s squared. So I'm going to change s to x just because I find it easier to work with variables I'm more familiar with. I'm just going to make a note to myself that s equals x. And then I'm going to divide that by 4 tan, and then in parentheses we'll write 180 over, and the number of sides is of course 6. And then we can simplify this. And so what is 180 divided by 6? Well, that's just going to be 30. And so what can I type in my calculator? I can type in 4 tan, and then in these parentheses I can just write 30. Now tan is not exactly a constant like pi. It's a little bit more complicated than that, but you can think of it as a constant like pi for the purposes of this class, and you don't need to know what it is. You just need to know that you can type it in your calculator and it'll give you the answer. And if I hit enter, I will get some rational number. If I don't like that number, and I don't because we are dealing with precision here, I'm going to go ahead and hit my conversion button and I will get the actual answer, which is 2.3. And so I can rewrite this to say 99 equals 6x squared divided by 2.3. And if you're wondering, we didn't have to write 30. We could have kept this as 180 over 6. So I can say 4 tan 180 over 6 instead and not simplified this. And I would get the exact same answer. And if I hit the conversion button, I will get the exact same answer for the record. But now all we have to do is solve for x now that we've simplified this equation. And again, this could be s. You could have wrote 6s squared if you preferred. Like I said, I just like working with variables that I'm more familiar with. And so to solve for x, I need to get x by itself. And so I'm going to multiply by 2.3 on both sides. So multiply by 2.3 on both sides. What do we get? What is 99 times 2.3? I get 227.7. So 2.3 is canceled out on the right, and I get 227.7 equals 6x squared. And then we can simplify further by dividing by 6 on both sides. And I'll divide by 6 over here. That cancels out. And what is 227.7 divided by 6? I get 37.95. And so I can say therefore 37.95 equals x squared. But I don't want to know what the square of this is. I want to know what it actually is. And so I need to get rid of that square as well. And the opposite of that is the square root. And so I'll take the square root of both sides. And what is the square root of 37.95? I get 6.16. And of course, it says precision of 0.0, which means round to the first decimal place. What do I get for this answer? Well, this 1 would round up to 2 from this, or because of this 6. And so I can write 6.2. And of course, my units would be, and we said inches earlier. That is very wrong. This should have said centimeters squared. Because it was measured in centimeters squared. Therefore, this unit would be centimeters. And I'm sure there were a few of you who are watching this video and thinking to themselves, where did he get that unit from? I apologize for making that mistake earlier. The answer should be 6.2 centimeters. Don't do what I did and mix up your units, because you will lose a point. And make sure you round to the correct precision, or again, you will lose a point on this exam. Let's move on to question 14. Question 14 asks, convert 50 milliliters to centimeters cubed. And so this is a very complicated formula, but I want you to go ahead and write it down. I'm going to say 1 milliliter equals 1 centimeter cubed, because when they invented the metric system, they thought it through and they wanted this to be a simple conversion, right? And so it's 1 to 1. So 50 milliliters would be 50 centimeters cubed. And that's it. That's the whole answer. And it says precision of 1, which just means round to the nearest 1. And hey, it already is rounded to the nearest 1, so we're done with that question. And finally, question 15. You are trying to ship out 6 centimeter puzzle cubes. Each cube weighs 0.5 pounds. If we ship it, offers a flat rate of $7.95 to ship a parcel up to 10 pounds. As long as it fits within an 18 centimeter by 18 centimeter by 18 centimeter box, how many cubes can be shipped in this box for $7.95? Okay, so I like to draw pictures to help me understand concepts here. So we'll draw ourselves an 18 by 18 by 18 cube to work with back here. And so go back a little bit and then go down a little bit. And then we'll just say, hey, this is 18 and let's fix that. And this is 18 back here. And then, of course, this is 18 as well. And on the inside of this, let me get a different color, we've got smaller cubes that we can fit inside this box. And so you can see that this little cube barely takes up any space. We could put another one right next to it. We could put another one behind it back here. And so if we draw it right, this one goes here and then there. Okay, we can fit a second one there, and we should be able to fit a third one back here since these are 6 long each. How do I get that information? Well, right here. And so how many can I fit in this? Well, I can fit 1, 2, 3 this way, and I can fit 1, 2, 3 this way. And so I can fit 9 on the bottom level. But then I can fit another 9 on top of those because it's also 18 centimeters tall. And I can fit another 9 on top of that. And so volume-wise, I can fit 27 of these little puzzle cubes inside this box. The question is then, does that meet my weight requirement or does it exceed it? So how much is 27 cubes? Well, 1 cube is half a pound according to this question. So 2 cubes would be a pound, and 3 cubes would be a pound and a half. And you see where I'm going with this. What is 27 times 0.5? And we get 13.5 pounds. 27 cubes equals 13.5 pounds. Okay, well, in this case then, that exceeds our 10-pound limit. And so we can't quite fit 27 cubes in this box. Okay, so how many cubes could we fit? Well, a maximum of 10 pounds. And so how many cubes would we have to lose to get down to 10 pounds? And the answer is it's 3.5 pounds over, and each one weighs half a pound. Therefore, if we draw this little thing correctly, therefore, we need to subtract 7 cubes, and we will end up with 20 cubes, which of course weighs 10 pounds. And so whenever you're doing a problem like this, you actually need to figure out the max volume and the max weight So the max volume was 27, the max weight in this case was 20, and you need to see which one do you exceed first. In this case, it was the 10 pounds, and so the answer would be the max amount of cubes I could fit in this box and ship it at $7.95 is 20 cubes.